Hello guys, today we are going to look into a different traversal which is called level order traversal. This is an important traversal, so it is used in many applications. For example, given an organization hierarchy, if we want to find people at a particular level. For example, if we need to find all senior engineers in the organization, so we should be able to get it using level order traversal. For example, all the senior engineers will report to a set of people who are called managers, and managers will go to the senior manager or whatever it is, right? Level order traversal has many applications. I've just given you one real example of where you can use level order traversal. So how it traverses is it traverses the tree according to each levels. It visits a root first, and it visits all children in that level, and it visits all children in the next level. It goes to the bottom and visits all the leaf nodes at the level. So it is a little different traversal. As I already told, we need to use a different data structure. We need to take help of other data structures to do level order traversal. So what we have done is we have created a tree, and probably we will be given a tree, and then we will see how to do level order traversal. We would take the help of queue to do a level order traversal. What happens is we visit the root node, and then we add all the children of that root node to that queue, and then traverse when the queue is not empty. We keep pulling out nodes, or dequeue the nodes from queue. We take all the children, add to the end of the queue. So it goes like this. Uh, Take the root node, add it to the queue, and when do till the queue is become empty. So it goes like this. If your queue is like this, I push first a node here, and then I take the first node out, and then check if that node has any children, push it to the queue, and then take that first node, because queue follows first in first out principle. So the root node gets visited first. All the child nodes of that will be enqueued, and then till when the queue is not empty, it goes to the next node. Take all the child nodes, visit it, take the second node, all the child nodes of it. I would uh, put it like this. Okay, so if the root node is 1, and the left node is 2, and the right node is 3, and the left node is 4, the right node is 5, and for this, for 3, it is left node is 6 and right node is 7. So let's not get confused whether it is a tree or a binary search tree or a binary tree. It's just a binary tree, it's not a binary search tree. So how do we do the level order traversal? Take the first node, push it to the queue. When queue is not empty, so the queue is not empty now. So what I need is I take the I dequeue from the queue. I take the first node, print. So and then take the first node. I will check if the tree has left node. Yes, tree has left node, which is 2. Enqueue enqueue or 2 enqueue to queue. If the tree has right node, yes, enqueue 3. Okay, so now what we need to do is whenever once I visit this, I'll check take out all the nodes which are printed, and then that's a different array. So what we did first, we took the first node, push it to the queue, we take that node out, and because the queue is not empty, and then check if 2 has left, if it has a left node, yes, if it has a right node, push it. Now again queue is not empty, right? What I would do is I would take the first node out, which is 2, that's the one which we first pushed. So queue follows the first in first out principle. I take the 2 and I print, and then check if the 2 has left or right node. Yes, 2 has left node. Then here enqueue 4. If 2 has right node, yes, enqueue 5. Then I would, what is the next node which is available in the queue? So at this point of time, after this the queue, okay, it is easy to represent, right? The queue has print the node, so queue has become empty. After this the queue is having 2 comma 3, and after printed the queue has 3 alone. Now the queue has 3 comma 4 elements here. Now the 3 contains 3 comma 4 comma 5. So what we did now, we go to the next node, which is 3. Print print means I am not just printing, I am dequeuing from the queue. Print 3, and then I check whether the 3 has left node or not. Yes. Then enqueue 6. Now the tree contains 4 comma 5 comma 6, right? Yes, 4, because I've taken 3 out. Then if it contains state, yes, it contains state. Enqueue. Now the tree contains, so it's like enqueue of 5. After that it would result in a tree like this. Enqueue of 6, which would result in a tree like 4, 5, 6, 7. Okay, if you note it, enqueue4 which result in 3 to 4, enqueue result in 3 to 4 to 5, 2 print 3. Okay, so this if you see it, I printed the first node and I enqueued 2 2 to the queue. So now the queue will become 2, and now the queue become 2 comma 3, then print 3. So okay, so this is a very decent walkthrough. Now I have queue, push 1 to the queue, it has left, push 2 to the queue, and then push 3 to the queue, and then take 2 out, push 4 to the queue, not push, enqueue 4 to the queue, and enqueue 5 to the queue, take 3 out, find what are the children's, 5 and 6 are there, enqueue it, and then since the queue is not empty, take every element out for print. Now print 4, 5, 6, 7. Nothing will get enqueued because all the children of 4, 5, 6, 7 are null. So this is called level order traversal. Go to every level and do it. If you need further explanation, I can do a whiteboarding. I try to do whiteboarding in my system only. I would certainly want to repeat the same thing again. We rely on queue structure because we take the node at every level and push it, and whenever we are pushing or enqueuing a node to a queue, we will check if that node has children and then push that. Enqueue that. Whenever we are dequeuing it, take that node, print it. After printing it, check if the node has left and right, then add it to the end of the queue, which is enqueue it. Dequeue, print, enqueue, dequeue, print, enqueue till the queue becomes empty. So this is how we do a level order traversal. Let me walk through the code. So this is a kind of LeetCode signature. Don't get confused by the list and all these things. If the root is null, I will return the entire the list which I am going to return, but I would return null if it is a different signature. I have used queue, which is of which can hold types of tree node, and I have used a queue linked list. You can use deck as well. Queue dot add a root. I have added root. When the queue dot size, I am doing a while loop till the queue dot size becomes queue size is greater than 0. I would take the queue dot forget it. This is this I have done for LeetCode. While the size is greater than 0, I would remove the element from the queue. I will add that to the current list. That also you can forget it, because you take the code, you clone my GitHub and then clone and then debug it. You should be able to understand. I don't want to confuse while explaining this. If the left is not null, I am adding it to the queue. If the right is not null, I am adding it to it. I am decrementing the size just to maintain till I traverse the current level and add it. It is for LeetCode I have done, but otherwise uh, and otherwise this is how we traverse the entire tree in a level order traversal. I hope I have made things clear. If still you need some explanation, I can do a whiteboarding on this problem. Thanks for your time. Let's meet in a different time with a different problem.